Hello, Algebra 2 people, and welcome to Chapter 4, Graphs of Polynomial Functions. Here we go. Okay, so we've spent a lot of time on quadratics, and now we're going to expand that to higher order polynomials as well as quadratics. So we're going to look at polynomials, and this is sort of the general form, which looks kind of scary. But the main thing to realize is when you're writing a polynomial, the highest degree, or even the degree of the function, is based on the largest exponent, which you would find in that first term, and the number that occurs before that term is what we call a leading coefficient, and I tend to abbreviate that as the LC. And notice this plus c. If you remember from quadratics, the plus c always represented sort of our y-intercept, which it will also represent in any other polynomial, because when you let x equal 0, that is the constant that still remains. Okay, so polynomials, we write them in descending order of the power of the exponent. And in order to even be a polynomial, you must have an integer exponent or 0, but nothing else is allowed. No fractions, no negative numbers. So notice in this list below, we have what are polynomials and what are not polynomials. So in this case, the square root of x, which actually equals x to the 1/2, that is not allowed, so that's not a polynomial. In this one, notice that x is in the denominator, so it looks like, but it has an exponent of 1, but you can rewrite that with a negative exponent. So that makes that one not a polynomial. Here you can already see we have a negative exponent, so that's why that's not a polynomial. And the fact that you have x in a denominator would also make that term with a negative exponent. What we do like is, so integer exponents on the x, this actually is x to the 0, nice linear function. And notice it's okay to have a radical on the numbers, just not on the power of your x. So how would we classify these? Well, here your degree is 2. Second degree equation, we call that a quadratic. That's the one we've been doing so much work with. Here, if I had y equals 5, your degree is actually 0. This is called a constant because it's basically a horizontal line. Here you should know this one is linear. And here my degree is 4th degree, so we call that one a quartic. All right, so you do want to be able to recognize what is and what is not a polynomial. Another thing you want to be able to do is evaluate the polynomial for a specific number. And this is going to play a bigger role later in the chapter when we decide whether something is factorable or not. This is one of the skills we'll use. So we're going to be plugging in -2. So just make sure when you do put it in, especially negatives, put them in parentheses. So again, the only thing getting cubed is the -2 plus 2 times -2 squared minus a -2 plus 4. And so then we're going to simplify this out. So 3 times -2 cubed, is a -8. And then I have 2 times -2 squared, which is 4. And then minus a -2, so that's plus 2 plus 4. So we have -24 plus 8 plus 6. That is all going to give us -10 as a final answer. And of course you can use a calculator on those, but I'm just showing you the process. Okay, now we're going to start getting into looking at polynomials and writing them in standard form. So remember, standard form means that the powers of the exponents should be are written in descending order. So the highest power comes first, then the second highest power, etc., etc. The highest power is what gives it the degree. So we'll write that, the highest power of the exponent. exponent equals the degree of the polynomial. And the number in front of that again is also the lead coefficient. Okay, so we have here example 2. They want us to write it in standard form, so we have to reorganize our terms, and then identify the degree and the lead coefficient, which is what you want to do after you've written it in standard form. So I look through here, I have third degree, I have an exponent of 3, I have an exponent of 1, and an exponent of 4. So I take the highest exponent, and that comes first. So 3x to the 4th, then comes x cubed, then comes 6x. And so once we have it in standard form, we can see that our degree is 4, and the leading coefficient is a positive 3. Now what about this second one? P of x equals x plus 2x to the negative 2 plus 9.5. Hopefully you kind of recognize that there is a negative exponent here, which means this is not a polynomial, so we don't have to do anything. Haha. All right? Awesome. Now comes sort of the fun part. This is hard to convey through a video because we did a lot of waving of our arms. But one of our goals here is to have you plot as few points as possible to be able to sketch a graph. So there are certain things you can look for. An odd degree function, that means the highest degree is going to be, say, 1, 3, 5. So the degree is going to be an odd number. And if the lead coefficient happens to be a positive number, then what's going to happen is your final end behavior is going to be going in the up in the positive direction, and the two end behaviors are going to go in opposite directions. This is really hard to convey through a video. So odd degree, first of all, the fact that it's odd means your end behaviors in opposite directions. Let's get that across. So why don't I put that here? So odd degree, we want to be end behavior is in opposite directions. All right, now we know that this is the x-axis, this is the y-axis. We know that this is positive side, this is a negative side. So this is a negative infinity, this is a positive infinity. We want to look at what is happening when the end behavior is going what is the end behavior when x is going off to positive infinity, or when x is going to negative infinity. So if it's an odd degree with a positive lead coefficient, this is based on the positive lead coefficient. The end behavior is going in the positive direction, but I want to know as x goes to infinity, what is y doing? And the way you figure that out is by putting plus and minuses at the end of each of my quadrants. I can circle these two to go with this behavior. So as x is going to a positive infinity, y is also going to a positive infinity because the graph is going up. As x is going to negative infinity, I find where my graph is ending, and it seems to be ending in that quadrant. That means my y is also going down, so it's going to a negative infinity. And we're going to do that for each one of these. So again, now if I have a negative lead coefficient, but it's still an odd function, so I'm going in opposite directions, but that negative, it's like when you had a is negative and the quadratic was a frown. Well, now your final end behavior, because that's what the lead coefficient determines, is going down, and that's because of that negative lead coefficient. But I still have x going to infinity, negative infinity, y is going to positive infinity, and negative infinity. So we are going to look at, as x is going to a positive infinity, what's happening to y? Well, in this case, it is going to a negative infinity. And correspondingly, as x is approaching, I should have written that on the other side, sorry. Let me erase that. As x is going to a negative infinity, what's happening to y? Well, we look at the graph. As x is going to the negative infinity, the graph is going up, so y is going to a positive infinity. All right, so this is what we mean when we talk about the end behavior of a graph. You have two ends. You sort of have the beginning, and you have the final end behavior, which is what the leading coefficient talks about. Now, to make it a little easier, if it's an even degree, meaning the highest power is like 2, 4, 6, then the end behavior is the same in both directions. Think about a quadratic. They're both either going up or they're both going down. Because of that, we can simplify writing our end behavior. So again, here's my x, positive infinity, negative. For the y, the positive infinity and the negative. So as x is approaching both plus and minus infinity, because it's going to be the same, we can say that y is going to a positive infinity. So this is a graph with a positive lead coefficient that is also even. So both of these are going to go in the positive direction. And then down here, this is an even degree function. Whoops, hey, what happened? Where did you all go? Sorry, something happened there. So this is, here's my positive infinity, my negative, positive infinity, negative. All right, still an even degree. Notice you're both ending in the same direction. Negative lead coefficient, so this is like when a was negative and you had a frown for your quadratic. So we know that as x is going to both positive and negative infinity, the y values are approaching, in this case, negative infinity, because they're both going down. So it might be good to kind of practice, you know, we held our hands up, held our hands down, kind of what the different possibilities are. It's all about the end behavior is all about your right hand. So a positive lead coefficient, regardless of odd or even, your right hand will be up. If it's even, both hands will be up. If it's odd, your right hand is up and your left hand is down. And then if it's a negative lead coefficient, for odd you would switch. Your right hand would be down, your left hand would be up. So you might want to practice with those for a bit. Okay, so let's see how good you are with this. So we have 3 examples of different graphs. Describe the degree, even or odd, the leading coefficient, whether it's positive or negative, and the end behavior. And we're also going to kind of tackle what a potential degree might be for each of these. But let's start off with the even, odd, positive, negative. So notice my end behavior is in the opposite direction. So that tells me this is going to be an odd function. My final end behavior is going up. So that tells me my lead coefficient is going to be positive. And something I want to point out is something we call turnarounds, max or mins. So notice I have a turnaround here. There's 1, here's 2, here's 3, here's 4. I seem to have 4 turnarounds. Now we did say that we think this is an odd power, so it turns out that this would potentially be a 5th degree function, because that should also be an odd number since we said this is an odd degree. All right, hang on to that because we're going to look for a pattern as we do this. This middle one, well, look at my end behaviors in the same direction, so that means it's going to be, you can fill in the blank, even. And because they're both going down, that tells me my lead coefficient is going to be negative. And let's look at these turnarounds. So we know it's an even function. It's obviously not quadratic. So I have 1 turnaround, 2 turnarounds, 3 turnarounds. So I have 3 turnarounds, and I believe this is probably a quartic, so a 4th degree function. Okay. Let's look at this last one. So I'm going in opposite directions for my end behavior. So what does that mean? That means odd. And I know that my leading coefficient, since the end behavior is going down, that means my lead coefficient was negative. Now let's look at these turnarounds. So I have 1, I have 2 turnarounds, and this is a cubic function. So hopefully from that you see a pattern that your degree is always going to be 1 higher than the number of turnarounds, which is a nice way to figure out what your degree is. Okay, so let's kind of summarize that. Even degree, the end behavior will be the same. So quadratic, quartic, 6th degree, end behavior will be the same. Odd degree, your end behavior is in opposite direction, so odd for opposite. And number of turnarounds will always be 1 less than the degree. Make sure that if you say that it's an odd function, you give a degree that is an odd number. So 1 less than the degree. All right, so here we have some examples. Here's a constant function. So just kind of going there. 0 is neither even nor odd, so it doesn't go up and it doesn't go down. Linear function, positive lead coefficient because it has a positive slope. Here's a quadratic, notice 1 turnaround. Cubic, 2 turns around. Quartic, there has 3 turnarounds, and a quintic, which is a 5th degree. Okay, now for the last part. These are a little bit, they're kind of fun. They're puzzles. It takes a few. You're going to have another one on the classwork and in the homework, so it's definitely worth practicing. These are a little difficult. So we have some clues, and based on these clues, we are going to be able to sketch a graph. So you have to know how to read the clues. So the first clues, that tells us about the increasing and decreasing. So it's also telling us about where our max or our min are going to occur, because when you go from increasing to decreasing, you hit a maximum, just like we did with our quadratics. The second set of clues, that's going to tell me not just where my graphs are above the x-axis or below, but they tell me what my x-intercepts are going to be. So I always like to start with the bottom 2 clues. So all the numbers there are going to represent where I'm going to cross. So here, remember, f of x is just another name for y. So y is going to be positive between -2. Actually, I'm going to label these. I'm going to spread it out. So let's just spread this out a little bit. So here's 1. These are all negative, sorry. 2, 3, 4, and 5. Okay. I'm going to cross at -2, at 3, and at 5. Now, why? Because when I read this through, y is greater than 0 between -2 and 3. So what I'm going to do between -2 and 3 is I'm going to put little tiny plus marks here above the line, because that means my graph is going to be above the line there. All the y values will be positive. And for x is greater than 5. So after that, I'm also going to be positive. Then it says y is less than 0, meaning the values will be underneath the x-axis for anything before -2. So these are all going to be minuses, and between 3 and 5. Now all that tells me is whether the graph is above or below. I don't know where I'm increasing or decreasing yet. So we go to this first set of information. It tells me that f is increasing when x is less than 0 and when x is greater than 4. So I'm increasing up to when x is 0. And then I'm going to be increasing after x equals 4. So that means I have a max or a min at x equals 4, and I'm decreasing between 0 and 4. Okie dokie. So at 0, I was increasing up to 0 and decreasing after it. So that means, if you kind of look at a number line, if this is 0, I'm increasing up to 0 and decreasing after it. That means you're hitting a maximum right there. So I have a little kind of maximum going. So what that means is my graph is increasing, and then I have to cross at 2. So notice I'm below, then at 2, now I'm above, but I'm still increasing. I increase until I hit 0. So that's my maximum. Then between 0 and 4, I'm decreasing. So at 4, I'm decreasing up to that point. So I have to kind of come around, go through this point at 3, and then I hit where I'm at 4. After 4, this is this last part. I'm increasing again, but I'm on the negative side. So notice I have to come up, get through 5, and I just keep increasing from there on out. So they take a little bit of time. So the way I recommend it again is use the second set of clues to mark on your axis. Those points, without even reading it, those are where you're going to cross the x-axis. Those are your x-intercepts. And then you can keep track whether you're above or below the axis by the little pluses and minuses. Notice that ours correspond. Wherever there's a negative, my graph is below. Wherever there's a positive, my graph was above. Then for the increasing and decreasing, those are going to represent your turnarounds, any of the numbers that are mentioned. So notice you're not turning around at an x-intercept, you're turning around usually in between your x-intercepts. So then you just want to then map out how you are increasing to your turnarounds, decreasing to your turnarounds, and then increasing again. All right, so hopefully that makes sense, and you'll get some practice with that with the classwork.